And I'm going to switch over. Give me just a second here. Okay. Document camera is right here. Okay. There it is. So now you can see what I'm writing. Area between curves. Basically, the idea behind what we're about to do is that if I have two different functions, we're going to call this one f of x, and we're going to call this one g of x. So I have two equations. And instead of just trying to find area under a curve, which would just be the area between that function and the x-axis, instead we have a certain region, we'll say from points A to B, where we are trying to find the area that is between those two curves. So not all the way down to the x-axis, just what can I find as, my cats are fighting again. Just what can I find as the area between those two curves? And if you think about it, really what I can do to solve this is just find, first of all, what's the area that's underneath my f of x function, and subtract from that the area that would be underneath the g of x function. So if I can find those two areas and subtract them, what I'm left with is just the area that is between them. I've got people still popping in, so that's okay. You know, if we think about this in terms of integration, that means that if I first find the area that is underneath the f of x curve between my boundaries, and then I find the area that is underneath g of x between my boundaries, and I find the difference between the two, what I'm left with is a value that is the area between those two curves. And it doesn't matter if you know, g of x goes under the x-axis. We're not worried about that. We integrate one, we integrate the other, we find the area in between. And in fact, because we're using the same boundaries and we have two functions of x, I don't have to treat it as two different integrals. Instead, I can say, well, I could just algebraically find the difference between those two functions and integrate that difference between my boundaries. So I can kind of do the algebra first, change it into a single integral, and integrate that difference function, and the answer that I get will be the same value as what I would have found if I were to integrate them separately. Okay, so that's kind of where we're going. So I'm going to show you an example of this, and then I'll give you guys one to kind of think about on your own. But let's just start with this right here. So this is the document that I posted in Google Classroom of the problems we're going to be doing in class. But they'll be sitting right here. So these kind of problems can start out, this is kind of our first case where they give us some equations, y equals x plus 3, y equals x squared, that's my two functions. I'm trying to find the area that's enclosed, so what's between them. And they've also given me some boundary values. So these equations right here are boundaries. The other two functions are my f and g functions. I don't know which is which, it doesn't really matter which one we name. But one of the key things that I'm going to ask you guys to do on all of these is, oh, there's more people showing up. Okay. One of the things I'm going to ask you guys to do is to, first of all, draw a picture of what these functions look like. So first thing here is, here's my XY axis. It doesn't have to be a perfect drawing because you guys all know I can't make a perfect drawing. Just a general sketch. And the reason I'm doing this is because in order for me to do this process properly, I have to know which is the upper function, which is the lower function. So I know y equals x plus 3 is linear. So y equals x plus 3 is that guy. Let's grab another color. Y equals x squared is a parabola centered at the origin. So it looks like this. And once I draw them, it's pretty clear that this one right here is going to be my upper function, because that's the one that's farther away from the x-axis, and the parabola is going to be my lower function, because it's lower in terms of which one's closer to the x-axis. This right here is the area that I'm trying to find. Oh, but wait, I don't want all of that area because I have those boundaries. So here's my negative 1x, which gives me a boundary right here. Here's my positive 1x, which gives me a boundary right here. And I'm really just trying to find the area between those two x values that's trapped in between those two curves. So right there, that sketch, that scribbly blue, that's what I'm trying to find. So I am going to integrate that because they've told me these boundaries, I'm integrating from -1 to +1. And my equation always looks like, I'll write this up here, the upper function minus the lower function. So that means the upper function is the linear, x plus 3. The lower function is the parabola, so x squared dx, which means it's going to look like this. 1 to 1 x plus 3 minus x squared dx. So this right here, this is called my integral expression. Right now, we just finished all these chapters on how to integrate. So I'm not super concerned at this moment to check to make sure you guys can figure out your definite integral correctly. So what I'm asking you guys to do, make your sketch, get to the point where you have an integral expression that you could integrate. So you have your boundaries identified, the +1, the -1, you have your equations written out, and from here, you can grab your graphing calculator and you can evaluate it using your graphing calculator. If you don't remember how to do that, I have posted a link to a YouTube video that walks you exactly through the steps on how to put the stuff in your calculator. There's kind of 2 ways to go about doing it. And so integral expression is where we need to go. And then after that, we're really just looking for what the answer for that is supposed to be, because it's definite integration, and this one ends up being 5.333. So 3 decimal places of accuracy. That's an integral we could do by hand if we wanted to, but in the interest of time, we're just kind of use our calculator. Okay, so that's kind of the basic process. Any questions that you guys have about what I just did before I put you on one to kind of try and set up on your own? Or if you're okay, give me an okay. Oh, there's my cats. I don't know why they want to fight in here right now, but if I close the door, they'll just scratch at the door until I let them in. Okay, all right, looks like you're all good. Okay, so let's just shift this piece of paper up and look at this next problem. So this one, I kind of, yes, you can make that a 5 1/3. That's totally okay. If you do it by hand, you'd probably end up with a fraction, but either way is fine. So here's our next equation. Let's see if I can focus a little bit better. I have y equals 3 over x squared. Y equals 3, those are my 2 functions. And then I have boundary values of -4 and -2. So I want to give you guys a chance to see, can you sketch that out? Can you figure out what that's going to look like? Can you determine what your boundaries of integration are? So I want to just give you guys a couple minutes to just kind of poke at that one a little bit. Do you remember what the function 3 over x squared looks like? If we were in class, you guys would all be waving your hands in the air right now. But basically, let me see if I have an extra piece of paper. That function is going to look roughly like, I'm just drawing this guy over here. That's what like the function 1 over x squared or anything over x squared looks like. It's just has asymptotes at the x and y axis, and it's all above the axis. So that's kind of what our equation is going to look like. Y equals 3 is a horizontal line. Is that a question, Vanessa? Again, this is your time to work this one out. See if you can throw it in your calculator and get an answer for it. Sorry, today's mug is from Seattle. Let me see. I don't know if you guys can still see me. I can see me in the corner. Yes, Aiden, it's completely horizontal. How do I determine which is the upper and lower function? That's why we want to sketch them, because that way we can visualize and see which one's the upper function and the lower function. Sometimes it's hard to know, so you can always use Desmos if you're not sure what those graphs are going to look like, or you can just use your graphing calculator. Sometimes just the nature of the functions kind of tells us which one is going to be above and below, and we'll see that in our next couple examples. My cats need to stop fighting. Oh, good. I'm glad you can still see me. Okay, so if I'm going to sketch this out, I know you guys are still working on it, and that's okay. Here's my XY axis. There's X, there's Y. 3 over Y, or 3 over X squared is going to do this. So that's 3 over X squared. I always label these just so when I go to set up my integral, I know which one's which. And then, oh, it's a terrible graph. It's very slanted. Oh, well, sorry. And here's my horizontal line. This is Y equals 3. So assuming it, you see, right now, I still don't really know which one's the upper function and the lower function until I put those boundary values in. And this one has my boundary values over here at -2 and at -4. So here are my boundary lines. They're right there and right there. And when they cut this apart, I can see the only region that's bounded by all 4 of those lines is that one that I just shaded in. And it's why it's really important, first of all, to draw that picture to really be able to visualize it, because it would be easy to think, oh, maybe it's this little region down here. But notice that that region's not between those 2 lines. It's only underneath the 3 over X squared. And so I draw the picture so I can really see which way this is organized. Tells me that the Y equals 3 looks like it is my upper function because it's the one that's farthest away from the X axis. The 3 over X squared is my lower function. And these again are the boundary values from -4 to -2. So the integral expression I'm going to set up for this, I'm integrating from, and again, they told me my boundary values, so I don't have to worry about that, -4 to -2. And then the upper function is the 3. The lower function is the 3 over X squared dx. And that's what I am going to integrate. Now this one you could totally integrate by hand if you want to, because it just integrates to this from -4 to -2, or you can put it in your calculator. And oh, there's more people in the waiting room. Let's let them in. And according to my calculator, the answer for this one was 5.25. Okay, so how do we do on that? We do okay? Does it make sense? Do you have any questions? What would you like to know? Okay, Kayla, that's a good question. I actually wouldn't be able to solve it if the boundaries were from -2 to 2 because of the asymptote behavior for 3 over X squared. So they would not be able to ask me that. Okay, I'm going to check my time. Okay, good. We still got some time. All right. So this is kind of the first case we can look at where we're clearly told, here's your functions, here's your boundary values. Makes it nice and easy for us to solve that kind of a problem. Now, one of the other cases, hey, go away, is this one. Sorry, that's my cat again. We're going to look at question number 4 right here, where it just says determine the boundaries and find the area or the region enclosed by the curve. It doesn't tell us what the boundaries are. We have to figure them out for ourselves. And so on a problem like this, again, my first step should be, let's make a sketch of it. What have we got here? I've got a horizontal line and I have an upward opening parabola. I don't know exactly where that parabola lives off the top of my head, but I do know there's my XY axis. I'm going to draw the line Y equals 3 on it. And I know that upward opening parabola. I don't know where its vertex is. I don't know where it intersects anything. I mean, I don't know this stuff off the top of my head. And so all I know is that the only thing that could possibly happen with it is that it does something like that. It intersects that line in two places. It could be below the axis. It could be somewhere where it is. I mean, I do know that it intersects at 3, but we'll pretend I didn't know that right now. It couldn't be above, because if that was above that line, they would never intersect, and I would never be able to find points of intersection. So when they give you a problem like this one, those two things have to intersect. So this is really my only option, is that it intersects in two places like this. So I can see right here that this is the area that I'm trying to find, because that's the only area that's enclosed by those two curves, which means I need to figure out what my boundaries are. And the way I find the boundaries is to set those two equations equal to each other. So let's do some algebra. I need to figure out where 2x squared minus 8x plus 3 intersects the line y equals 3. So I'm just going to take my two equations, this one, set them equal to each other and solve this. It's quadratic, so the only way for me to solve it is to make it equal to 0. So let's subtract 3 from each side. We get 2x squared minus 8x equals 0. Greatest common factor is a 2x. So I factor out a 2x. I don't know what my cats are doing right now. And x minus 4 equals 0, which tells me that my two intersection points are x equals 0. And from x minus 4, I get another boundary value of x equals 4. So that's what these 2 points are. This is x equals 0. This is x equals 4. Okay, those are my integration boundaries. So I'm going to integrate from x equals 0 to x equals 4. And like I can see, the horizontal line is the upper boundary. So I'm going to put a 3 first. I'm going to subtract the lower function, which is this quadratic right here. So minus 2x squared minus 8x plus 3 dx, the whole thing. And like I said, at this point, I'm going to throw this into my calculator in order to get a value for it, because I don't really want to spend a ton of time going through the integration of that. I figured out what the answer was. Where did I write that down? I don't know where I put it. It's on the back of the sheet. Oh, there it is. Okay, when I throw that on my calculator, I get an answer of 21.333. Okay, so in the case where they don't tell you the boundaries, you have to set those equations equal to each other and figure out where those two functions intersect. You still need to be able to tell which is the upper function and which is the lower function. So again, your graphing calculator or Desmos or something like that can really help you on that. And that's what that process looks like. So if we look at this question over here, question number 5, we've got these two equations, a quadratic and a straight line. Which of those is going to be the upper function and which of those is going to be the lower function? Which one do you think? Let me know. Take a guess. Line, parabola. Right, because it's basically pretty much the same type of problem as of what we had before. It's not a straight line, but it's not a horizontal flat line, but it is going to be linear. So that linear equation for this guy is going to be slanting up like that. Again, I have a parabola, so I can just tell by the only way that those guys can fit together is that the upper function is the linear and the lower function is the parabola. Can you figure out what the boundary values would be? Can you set those equations equal to each other and determine your x values of intersection? Anybody have a guess at what our two boundary values are? There we go. Yep, those are them, 6 and 1. Good, right, because all we need to do to find those boundaries is set those two equations equal to each other. So I'm going to do x squared minus 6x plus 7 and set it equal to x plus 1. Needs to be equal to 0, so I'm going to subtract the x and the 1. X squared minus 7x plus 6 equals 0. And that will factor to x minus 1. X minus 6 equals 0. And that's where I get x equals 1 as one of the boundaries, x equals 6 as the other boundary. And so with what we know, that the line is the upper function, the quadratic is the lower function, and now we have our boundaries, I know that this area is going to be equal to the integral from 1 to 6 of the equation of the linear minus the quadratic, x squared minus 6x plus 7 dx. So there's my integral expression. Remember, that's the piece that we look for to make sure everything's set up properly and you have your boundary values. And that in my calculator, it told me it was equal to 20.833. Now, if you work through one of these problems and your answer is negative, what that tells you is that you've switched the order of the equations and you have put the lower function first. You can't have a negative area between two curves. It has to be positive. So in that case, don't erase all your work. You can just kind of write out, you know, my integral should have looked like this, and my answer should have been this positive number. So you have that option. There's kind of a third case that I'm not going to have you guys work on right now, but it's the idea, what if I have two functions, like one does this and the other one cuts through, right? Can you see how I've kind of got these two different areas? Section A, the linear equation is on top. Section B, the curved equation is on top. I'd actually have to solve that as two separate integrals. I'd have to figure out all three of these intersection points and set up one integral for A that has the linear equation on top, or first, one integral for B that has the curved on top, and separate those out. I'm not asking you guys to do that right now because that's a little bit more than we can kind of introduce. But basically, this is where we're at. These two options where you know your two functions and the boundaries, or you have two functions, you have to find the boundaries and set it up. But again, that's, you know, that's why I highly, highly, highly recommend that you draw a graph, sketch a graph, look at it on Desmos so you know which function's the upper function, and then set up your integrals. And like I said, use your calculator to find the answer. We don't need to spend a ton of time integrating by hand right now. That's not our focus. Our focus is the understanding of this concept. So how you guys feeling about that? Does it seem okay to you? Thanks, Joe. Okay, looks like you guys are feeling confident about this, which is great. It's not a huge, the math part of it is not new, really. It's just the idea of, oh, we have to figure out the order of things and the boundaries. So wanted to remind you guys, I do have office hours set up tomorrow from 1 to 2. It'll just be a Zoom that's open. Anybody that wants to come can come. It's open for all of my classes, so there might be stats kids in there too. And I'm also going to be posting, like I said, answers to the homework from the differential equations assignment. I believe the worksheet that I posted has the answers on it. If I remember correctly, it just has answers on it. So for the homework assignment, once you've completed the homework assignment, just post a photo of it to that, yeah, on Google Classroom. So once you're done with it, just take a picture of it and upload it into Google Classroom so I can see everybody's homework. Otherwise, there's the office hours on Thursday if you have other questions, or if anything else comes up, just drop me an email. Friday is kind of the day that I'm like working on stuff. I'll be grading things. I'll be emailing you back and forth, hopefully talking about, you know, if there's extensions or reperformances and stuff. I still don't really know how that's going to work right now. But that's going to be on Friday. So if you have any questions, drop me an email. Otherwise, we meet again on Monday at 9:45. Thanks. I believe in you too. But that's it. So I guess I'm done for the day. How you guys doing? You ready to face the rest of your morning? How'd your first class go? Oh, there was no Zoom. Awkward.
I didn't have a class.
Oh, well, yeah, some of you have like open periods and stuff.
I made breakfast.
Oh, well, that's nice.
And I made cinnamon rolls, and they were hands down the best things I've ever made.
You shouldn't be telling us that. No one wants to hear about your cinnamon rolls when you can't share them with us.
Yeah, I'm just eating Cheerios. I already had breakfast.
Yeah, David made me breakfast while I was doing my first class because he's a TA for pop culture. So anyway, all right. Well, so I am going to stop this recording. It will be posted into Google Classroom shortly. And then I will either hear from you guys by email, office hours, or I will see you online on Monday. All right. Thanks, guys, for showing up. Enjoy your weekend. Take care. Stay safe. Don't get sick. And we're out. Bye.